Whenever we think about data structures, we usually think about stack, queue, linked list, all these things, right? But when you program with JavaScript, you're building application with JavaScript, it's all depends on your use cases and how you want to handle data. And that's where the data structure come into picture. JavaScript has some inbuilt data structure support using which you can create many other data structure again based on the use cases that you have in hand. We have already learned about objects, isn't it? The key data structure exists in JavaScript with key and value pair. We have learned about arrays, which is a data structure that allows you to store the sequence of elements together, and especially in JavaScript, the element can be of any type. Apart from arrays and objects, there are few more types of data structure that you can utilize to tackle data for your application. For example, it has map, it has set, and it has its twin sisters, WeakMap and the WeakSet. So in this video, today's session, we are going to focus on understanding what is map, what is set, what is WeakMap, what is WeakSet, along with where exactly they will be playing a key role in your application development. After this session, you will have knowledge about these four data structures plus objects and arrays. So six data structures. Using that, I believe in JavaScript, you will be able to solve multiple use cases and multiple problems around data. So big question, what are you going to learn today? We are going to learn a lot of things. If you have patience and that curiosity, I'm sure that you're going to like today's session. We'll start with a quick 2 minutes recap of arrays and objects. Then we'll get started with map in JavaScript, how to add values to map, how to get values from map, all about the keys in map, map properties, different methods. We'll talk about map iterator, how to iterate over map, how to convert one data structure to another. For example, an object into a map into an object, a map into an array. Because when you are building real world application, your API may be giving data in certain format. You have to convert that in a way that your UI understand and the data structure of the UI require it, right? So why these conversions are pretty handy and important for you to understand. Then map versus object. When should you use and which one to use? Then we'll get into set, another data structure. How to create an initialize set, set properties and methods, how to iterate over set, convert a set into an array, again conversion. Then how to get unique values from an array using set. Then set and object, what are the relationship, how we can use them together. Then of course there are set theories like you have union, intersections and all these things. How can we accomplish that programmatically? Then we get into something called weakmap and weakset, the data structures that not many people talk or use a lot, but it's great to know their real usages, great to know where you can actually apply them in your programming, and you will be able to understand weakmap and weakset completely only when you understand map and set well. Okay, and also you have an understanding of objects and references that we have covered already in the initial sessions of 40 days of JavaScript. Finally, we'll talk about the task and assignments as usual, and we'll close this session. So you understand there are lots to cover. Let's get started with a 2 minutes recap of objects and arrays. In JavaScript, objects are used to store multiple values as a complex data structure. And how we create objects? We create objects using this curly braces, which can have a key where key should be of type string or symbol, and a value can be of any valid JavaScript type. For example, it can be a boolean, or it can be an array, it can be another object, it can be a string, or it can be number, all valid JavaScript data types. Now this is great because when you have an object and the value of the object can be of any type, it means that you can combine arrays and objects together to build a complex data structure that you need for your application. On the other hand, you have something called arrays. How we create arrays? With the subscript symbol, and inside that we can keep the elements in the ordered fashion. There are few other specialties of arrays. Array can accept duplicate elements. For example, I can create an array with the number 3 as many times I want. Also, in JavaScript, the array element can be of any type. You can actually combine the numbers with boolean, with string, whatever the ways that you want. Now, until ES6, which is also like ECMAScript 2015, JavaScript objects and arrays were the most important data structure to handle the collection of data. As I told, that you can have an object as an element of an array, you can have an array as the value of a key in an object, that array in turn can have another object, and inside that you can just keep going. Here also this object can have a key value pair whose value can be one array, and that particular array can have another object. So you can go nested to whatever extent you need for your application to work, right? However, though these complex combinations were working really great, there were still few shortcomings. Let's talk about those shortcomings one by one. The first shortcoming, if I have to talk, object keys can only be a string or a symbol. You cannot make any other data type as the key of an object. One shortcoming. Whenever you are inserting something in an object, multiple keys, objects does not maintain the order of the elements inserted to it. So for example, if I create an object like this, and if I insert a property called A with an empty string, another property called B with some string, there is no guarantee that whenever I query obj, I will first get the property A and then only I'll get the property B. It might appear sometime, but there is no guarantee that in this way only they will appear. Of course, the JavaScript object has some useful methods, but at the same time, it also lacks certain useful methods. For example, it is difficult for you to compute the size of an object easily. You can compute the size of an array very easily using the array.length properties, but object doesn't have anything as such like length or size property. So you really don't know straight away what is the size of a particular object. Also, enumerating object is not that straightforward. Of course, we have something called a reflect APIs in JavaScript got added. After that, it become a little bit easy. Still, it is not very straightforward. On the other hand, if I go to arrays, arrays are collection of elements, but it allows duplicates. We have seen. But if we want a collection where we don't want duplication, then it's a trouble. So supporting arrays that only have distinct elements require a lot of extra logic and code for you to write. So from all these aspects, from all these shortcomings, what JavaScript thought or the board thought is like, okay, let's give developer couple of more data structure that can mitigate this problem. That's how the map and set came into picture. So after this couple of minutes of introduction of arrays and objects and why, what was the motivation between map and set to coming to the developer community, let us talk about map in JavaScript. So what is map? Map is a collection of key value pairs. But hold on, object is also like a collection of key value pairs. Then what is there in map so special that we need map? Of course, map is a key value pair like object, but there are a lot of other dissimilarities or other advantages of using map. First thing, in map, the key can be of any type. But in case of objects, the key has to be of type string or a symbol. The second difference, map remembers the original order in which elements were added to it. In case of object, there is no guarantee of it. So as map can remember the original order in which elements were added to it, it means the data can be retrieved in the same order that they were inserted in. That brings down the complexity of accessing the data in the map data structure. Thus, it will be much more faster. So if you think, in other words, map has the characteristic of both object and array. How? Object is a key value pair, map is a key value pair. In case of array, the elements are sequentially in the order that they inserted in the array. Similarly, for map also, the elements in the map can be remembered in terms of their insertion order. So taking the best of both, we have a new data structure to deal with. Now the question is, how can we create and initialize a map? It's pretty easy. Let's do that. Const map equals to new map. The capital letter MAP map is given by JavaScript. This is a constructor function of the map given by JavaScript. You have to use the new keyword in front of the constructor function to create the instance or the object of it. That's exactly I'm doing. And then I'm assigning that object to this variable called map. What happened if I do console.log of map? Here I see the output. We have a map whose size is 0. We're going to talk about what size mean. And if I expand this one, I see it doesn't have any properties and the prototype of it is map. I hope you understand prototype because we have already given you a session with the prototype and prototype chain. If I expand maps prototype, I will see a bunch of methods that are given by JavaScript as part of the map prototype, thus by the map object, so that I can utilize all these methods on the map instances that I'll be creating. And ultimately, in the prototype chain, if I go down, I will find map is nothing but an object. Array also having a prototype of an object, map also having a prototype of an object. So everything is kind of extended from object, but added other functionality, the OOP principle, right? Inheritance, and then add their own functionalities to make them a specialized data structure like map. Okay. So we have created a map, but we have not really entered any values to it. But if you want to enter some values to a map, there are ways that you can actually do it. So there are a couple of ways. While creating the map itself, you can supply that using what are those key value pairs that you want to initialize this map with. For example, if I want to initialize this map with 3 key value pair, I will be inserting them as an array, and inside this array, each of the element will be another array. So I have added 2 arrays and then 3 arrays because there are 3 key value pair I am willing to insert. And in the first array, I will insert the key and value as 2 elements. For example, I can say name colon, the value can be say tapaScript. Then I can have another one entry, key value is a type. I can say YouTube, and then I'll say owner, and I can say tapas, right? So now I have created a map with 3 key value pairs. Now if I go to my output, here I am seeing the map now. The important thing here, now I see map with 3 elements. Okay. So if I expand this, here I am seeing in the entries, the first key value pair is name and tapaScript. Then type is YouTube and the owner is tapas. And the size of the map is 3. That means the map is having a property that can give me the length of how many entries are there. In case of object, there is no straight way of knowing this. For arrays, yes, it is there. So now we have created a map with some default values. The other way that I was telling that you can create a map without any default value, but later point in time also you should be allowed to add more values to it, isn't it? So we need to know how to add values to a map. To add values to a map, we will use the set method. The set method takes key and value. There, previously we were passing the key and value hard coded. Now we will be calling the set method by passing the key and values. Let's create a map first. Const map equals to new map, just like before. And now let's add values. For example, I can do map.set. Name is the key and the value is tapaScript. Similarly, I have added 2 more. So I have now 3 properties again for this map. So yes, now again I see them. Name tapaScript, type YouTube, owner tapaScript. So there are 3 properties. Size is also showing 3. So 2 ways that we have learned, we can create map and set value or create map with the default value initialization. Here one point to remember, if you use the same key to add a value to the map multiple times, it will always replace the previous value. For example, here I have added an owner property with the value tapaScript. Now after this, if I use the owner property again and set a new value, for example, let me say TS, for example. Now if I see the output, as you see, now the owner value is TS. Size is still 3. I'm not getting 4 values over here, one with tapaScript, one with TS. The tapaScript, the previous value, is now replaced with the new value, which is TS. You have to remember this because people make mistakes around these small things. As we know about setting the property and its value, we have to also know how can I get it. For example, I have created a map and then I have set multiple values to it. How can I get the value of a property from the map? Very, very easy. Just like the set method, now we have a counterpart called get. What get method does, you have to pass a key to it and it is going to give you the corresponding value. In case of set method, we had to pass both key and value and then create a new property in the map. Now, if you pass the same key to the get method, it is going to give the corresponding value for that particular key. So that's how get method works. Let's take the example of same map and try to query the type. Okay, so if I do map dot get and then do type and put this entire thing inside a console.log, and we'll also put type is so that we know when the log print. So type is, we are expecting YT, YouTube. Okay, so let's go ahead and check it out. Yes, I see type is YT. So I'm able to retrieve the value of a map by its property. So we are done with all these 4. We know now what is map, how to add values to a map, how to get values from map, all these things. Let's talk about map keys, because this is where it differs from object a lot. One of the advantage of map over object is map keys can be of any type. A primitive, also it can be another object. Okay, this is where it is very, very handy when you're going to talk about weak map. So this is one of the major difference between map and the regular JavaScript object. Let's take some example. Let's take a map called fun map, and we will initialize with a map instance. And now let's set few properties. For example, 560 comma, I will say my house number, and then I can also do true, and let's give a different value. Yes, I love teaching. So if you notice here, the key is a number. Here, key is a boolean. Now you can create an object like let obj equals to name, give a name, for example, tapas. And now you can use this obj on fun map with the set method, pass the obj as a key, and the value can be anything, any other valid JavaScript data type. For example, a boolean, right? So if you do a console dot log of fun map, you will see the real fun is now fun map will have three properties in this, and each of the property will have key of number, boolean, and the object itself. All right, this is the fun map. And if I look into the entries of the fun map, I have now three entries. The first one is the number versus the string, then the boolean versus the string, and then the object versus the boolean. That's how we had created. Now, if I expand this object one, in the key, I will see key is an object, name colon tapas, and value is the boolean that you have given is true. So you're seeing that the complexity is increasing in terms of handling the data in map, just because the key can be of any type. So you can create an object of user, the entire object you can create and keep it as a key, where the value can be anything that you can map with that particular user. Maybe the user's department, or user's salary, or user spouse, anything else can be value, and the entire user object itself can be the key of your data structure now, right? So these are the complex use cases that you will be able to handle if you have a data structure like map in use. All right, let's keep talking about keys. You have to remember one thing, that in case of regular JavaScript object, even if you pass a key as a number, ultimately JavaScript will treat it as a string only. But in case of the map, if we pass it as a number, it will be always treated as a number only. Let's check that out once quickly. Okay, I'll take the same number 560, but first let me create an empty object called fun obj. Okay, now taking the fun obj, let me use the same number 560. You're seeing that the 560 I'm not keeping inside any quote, is the number 560. Then I'll be giving the same value, say my house number over here, but only difference is previously I had dealt with a map, now I'm dealing with a plain JavaScript object. Okay, now if you do this comparison, what do you think the output will be? On the left side, I have the same fun obj using 560 as a number I'm passing. Again, there is no quote. At the right side, I have the quote, so it means it's a string. Is it going to give me true or false? Because I'm using the equality operator. So fun obj 560, now I closing, you will tell, okay, fun obj 560 is assigned with my house number. So this will give me my house number. And then fun obj string 560, what it is? It doesn't exist, look like. Is it going to give undefined? So am I equating undefined with my house number, and am I going to get a false? No, you're going to get a true, because this 560 will be coerced to a string 560. Here, do you see the output? It is true. But can you now do the same thing for the map? Here now I have done funmap.get, because that's how you get the value of a property, using the 560 as a number, as key, equating with 560 as the string. Is it going to give me the same? The 560 definitely has a value in the map which says my house number, but the string 560 doesn't have any entry. It means it is undefined. So now my house number as string equating with undefined is of course going to give me the false. So line number 90 is giving me the false, whereas in the previous one for the plain JavaScript object, we have got a true. So based on what data structure you are using, almost similar looking things but might behave entirely different way. Please be careful about it. Now let's talk about map properties and methods. We have seen previously like that map has got a bunch of methods, a property like size, right? So we can utilize these properties and methods from map directly. because we are creating an instance of this map itself. It means that everything that is there publicly in this map prototype will be available into the map instance of the map object. We have learned all this thing, right, from the S6 classes, prototype, all these chapters. So if I create an instance of this map, I'll have the delete method, entries method, for each, get, has, keys, everything, along with a property called size, which will give me how many entries are there in the map. So let's try them out one by one. Previously, we have created something called fun map. Inside fun map, we had added three properties, three entries, one with key 560, another with true boolean, another with object, right? So I can do console.log of funmap.size. Just like array has a length property, not a method, map has a size property we have seen. So this is going to give me the size of the map, means how many entries are there in the map, that is 3. Okay. Like that, we have other utility methods. For example, has is a method that we can invoke on a map to determine that if a map is having an element whose key is the key that I'll be passing to the has method. For example, I can do map.has. If I pass 560, it will give me true because map has an element whose key is 560. Okay, so if I do console.log, I'm going to get a true. Similarly, if I copy this and instead of 560, if I do 360, I don't have any entries in this map whose key is 360. I'm going to get a false. What if I give a string 560 instead of a number 560? Now it is just like the previous comparison that we made, isn't it? So now I don't have any entries in the map whose key is a string which is 560. I have with a number, but number 560 and string 560 are not same. So this is also going to give me false. All this has to be fun map, not map. So let's check now. In the DevTools, we are expecting 3 true, false, false. So we have 3 true, false, false. How we were expecting, using the size and then the has method, we got the output. Let's talk about few other methods. For example, from the map, if we want to delete an entry, again you have to rely on the key itself. So I can do fun map dot delete and then can pass the key of the entry that I want to delete, for example 560. Now what will happen after this, if I do console.log of fun map, I won't find this 560 entry anymore. As you see here, now my map is having only 2 entries. Previously map had 3 entries using 560 being the first entry, but now if I expand it, I won't see any entries with 560. So that's how the delete works. Okay, what if you have to clean up the entire map, like fully clear? As the name suggests, it is funmap.clear. Now if I do console.log of funmap, I will find funmap doesn't have any entries. Let's see that. So you see here, the funmap size is 0. There is no entries. If I expand, there are no properties and size is also 0. Okay, so delete will delete a single entry, passing the key. Clear is going to clear the map completely. So we used and learned few methods like has, clear, delete. Before that, we learned about get, set. After learning these methods and the properties, now we want to worry about how to iterate through map. Iteration means what? Iteration means you are able to go through the elements or the entries of the map. For that, we have a few methods that gives us the map iterator, and using the map iterator and some of the loops that we have learned already, we will be able to iterate through all the entries of the map. What are those methods in map that provides us the map iterators are the keys, values and entries, but with different purposes. If you have gone through the object session, you already know that we have discussed about keys, values and entries over there. Almost similar concept for map as well. So first thing first, let's create a map. We have created a map called age map. And while creating the map, I've initialized with few entries. One is Jack with Jack's age, Alan, Alan's age, Bill and Sam with their respective ages. Now our aim is to get all the keys. That means there should be some ways where I can get the collection of Jack, Alan, Bill and Sam together. To get all the values, that means there should be a way to get their age as a collection together like 20, 34, 10 and 9, and then get all the entries. It means that I'll be able to iterate through each of these entries one by one. So if these are my objectives, all these objectives can be solved using methods like keys, entries, values, all these things. Okay. So let's first talk about the keys. That is going to help us with getting all the keys. So very simple. I will do a console.log. I have the edge map already. The method on this is nothing but keys. Okay. If I do this, I will get a map iterator. Let's see what it is. So this is where it is, the map iterator. This is not a regular object. This is an iterator object that is given to us so that we can iterate on top of it. How can we iterate on top of it? We can use the loops like for each. You guys have worked on it, right? For each, for off. The edgemap.keys, the return value now I have taken inside a variable called MITR, which is like map iterator. And on top of map iterator, I can call for each, where I can get each of the element from the iterator and can do a console.log of each of the element. Now, what is edgemap.keys? Edgemap.keys is a map iterator. Inside that, I will have all the keys of this edge map, like Jack, Alan, Bill, Sam. But if I want to retrieve each of these Jack, Alan, Bill, Sam values, I have to do this for each, and that's where I'll be getting each of those key values printed like this: Jack, Alan, Bill, Sam. You got it? So once you get an iterator, you can do a for each on top of it to extract the value from the iterator. So one map iterator we have identified, which gives us the keys. Then how about all the values? If I want to get 20, 34, 10 and 9, simple. I'm going to do edgemap.values. So that's another method. So it is going to return me another map iterator with only the values. Now, once you have the map iterator, you know that you can use the for each on top of it to extract each of the values. For now, the line number 127, it's giving us a map iterator with all the values 20, 34, 10 and 9. Just do a for each to extract out each of these values. Okay, if we want to get each of these entries, key and values together, what we can do? As the name suggests, the method we'll be using is called the map.entries. Now we'll get each of these entries in the map iterator. We can use for each to get each of the entries. Pretty simple and pretty neat, right? So this is what returns me the map iterator: keys, values and entries. And after getting the iterator, we can use for each to extract out the values. But what if I have to iterate over the map itself and get the value? Can I do that directly without going through the keys, values and entries? Yes, you can do that pretty well. For that, you can apply the for each directly. Let's take up this one. I have this edge map, right? Now I'm not going to do edge map.keys, edge map.values or edge map.entries at all. Rather, I am doing edge map.forEach, getting the value and key over here, and I can actually print out the key means the Jack, Alan, all these guys is their age years old. This is going to work for sure. So line number 132 is going to give me this. Jack is 20 years old and is 34 years old. Bill is 10 years old. Sam is 9 years old. So this is an example where if you want to iterate over the map directly, then you can do it. You can still get the key and value. Remember, the first one what you're getting is the value, the next one is the key. Okay, so it's pretty simple. Now similar thing you can do using the for off also, the for off syntax. For off, you have the edge map. From here you are destructuring the key and value, and that key and value you are just printing just like before, console.log. So this also works. Either ways you can actually get this thing working. So I hope all these things are clear to you: how to get the map iterator, how to get only keys, only values, only entries, or how to iterate over a map itself. Because once you get this data structure, let's say you have to print the value of it on your UI, the entries, you have to know these methods. That's why it is useful. And that's where you also need to do the task, because in task you have a lot of things given as an assignment and for you to practice. Now let's look into all these conversions together. Let's look into converting an object to a map to an object, map to an array. Again, I told this before also, right? Your API might give a response in a certain data structure. You have to convert that data structure into something else that your UI layer might want. You have to know what are those methods that you have to keep in mind that will help you in this conversion. So let's see these conversions. First, let's convert an object into a map. Let's take an object first. That's my tiny whiny object, an address object, where Tapas stays in Bangalore, James is in Houston, Selva is from Sri Lanka. Now, I want to convert this particular address to a map. It means that each of this key value pair that I'm seeing in this address, I want to make it as an entry for the map. You remember when we used to initialize the map, we used to do something like new map, and if you used to initialize with value, we used to pass the entries like this individual arrays. So we are going to do something similar. That means we need to pass each of these entries as the individual array, where tapas will be one element, Bangalore will be second element, the first or second example whatever we have taken, right? Now I cannot hard code this, right? I cannot do something like take tapas over here and then do a comma Bangalore over here. Then same thing for James and Selva, for their addresses. That will be too much because this address can be dynamic. I can get this dynamically from my API. I have to convert it to the map. So it means that I need to have a method that will take this object as an input and output something of this structure. What is this method? In object, we have a method called entries. If you do console.log object.entries and pass this address. So line number 149, do you know what is going to print? It's going to print this exact structure that you're looking for to pass to the map constructor function to create a new instance of the map. Let's see. You see it over here, line number 149. There's the exact entry, first entry, second entry, third entry, an array inside that one more array where each of the elements are the key value pair kind of thing. Correct? This is the exact structure that we are also looking for. Now I can go to the code. Instead of passing this hard-coded thing, I can just take this guy out and then can pass this to my map, isn't it? I don't need this console.log anymore. And this is going to give my address map, const address map equals to, this is the code, right? Now if I do console dot log off address map, now here I go with my map. This is the new map. If I expand this, I'm getting all these entries as expected, and the size is also shown as 3. Correct? So what I did now, I had an object. I have now converted that object to a map data structure using this simple one line of code. Cool. Now let's go to the second conversion, which is about converting a map to an object. Previously object to map, now map to an object. Very simple. If you have a map, then use another method called from entries, pass any map. For example, now I can pass the address map again. What this is going to give me from entries, it is going to convert a map back to a JavaScript plain object. Okay, so I can now put it inside say ADDR and then console.log array. I'm going to see this address map now going to give me back. Here you go, is the object with a key value pair. James from Houston, Selva from Sri Lanka, Tapas is from Bangalore. Here you see the order of these properties is definitely not same as the original object that we had created, right? With the address there, Tapas was the first, then there was James, then there is Silva, but here you see the order itself got changed. So this says that for regular object, the order is never guaranteed, but for map, the order is always guaranteed. Okay, so we learned converting from object to map, map to object, vice versa. Now let's look into converting a map into an array. For that very purpose, let's take a map. So we have taken a map and added 3 entries, milk, tea and coffee with their prices. Let's say milk 200, tea 300, coffee 500. Now this is a map, we all know, but if you have to convert this map to an array, because in this map now there will be entries. We have seen it enormous number of time, right? How can you do it? You can do multiple ways. The first way that you can do, I'll print it also. There is a static method in array is called from. You can pass this map to this from method. This is going to convert this map to an array. So line number 166, if I go ahead and see, so if I see the output, this is no more a map. Rather, this is an array. And if I expand that array, inside this array, each of the element is also an array. And inside that you have the milk 200, each of the element in the subarray. Alternatively, if you don't want to use array.from, you can also use the spread operator on top of map to convert that into the similar kind of array that we have seen. We have covered all these conversion methods now. I hope it was useful. Please practice, please look into the task. That's when this will be useful, because if you're just listening to me, my lecture is not going to be that much useful. You should solve the problems that I've given using some of this. Generally, it will be very useful. So please do the task. Okay, now let's talk about map versus object. And when to use them, right? So this is a very crucial aspect of it. Let me bring out a comparison for you. So map versus object. Map has the characteristic of both objects and array. We have learned, right? Object means key value pair. Map is also key value pair. Array means is an ordered collection. Map is also ordered collection. Great. However, map is more towards an object than array due to the nature of how it stored the data using the key value format. Okay, now this is the similarity, and the similarity ends here only. There are a lot of other dissimilarity. That's what we need to talk about, and that is what going to decide which one you should use when. So here is what I go with. Use map when your usages for the data is not as simple as you can handle it in an object, simple object. Okay, you want to create a key value pair where key or you want it to be non-string values, like it can be an object, sometimes it can be a number, sometimes it can be a boolean. You might have that need, right? With object also you can do as a string, and when you're retrieving it after that, again you have to convert it into boolean or convert it into number. If you don't want to take those headache, rather you want to create a data structure where key can directly be a number or a boolean or can be an object itself. You have that need, don't go for object at all, go for map, because by default map is going to support that. Second, if you need a data structure where elements should be in the order and you don't want an array, in that case, you cannot go for an object because this is not guaranteed. We have seen, go for a map. Third, you are looking for flexibility in terms of how you want to handle the data from that array. For example, you want to get the length of it or the size of it without relying on any external library, like, we use something called Lodash before, like libraries like that, to manipulate the data and extract out the data from your object. Map supports, has values, trees, keys, properties, all these things together. So if you use all these things together, you can very easily extract out all those details that with object you have to always rely on an external library to do it. Correct? So these are the usages where you need map. Then when can you use object? Of course, if you don't need all these things that I've described, you are actually dealing with something very simple, go for object. You do not have any needs of any of those complexity. You rely on json.parse, as map cannot be parsed with json.parse, right? So on those cases, you have to rely on object. Otherwise, you can go for map. Many of us don't use this data structure so much. One thing is awareness. It came comparatively late into the language. And second thing is we always think that object or arrays by default going to solve the purpose. No, there are certain other things which can reduce your number of code, can enhance the performance of the things. That's what you need to look into. I hope you are clear now, map versus object. With that, map is over completely. Now we are going to get into something called set. Let us first understand what is set and then talk about other things about set. So what is a set in JavaScript? A set is a collection of unique elements. The keyword that you need to remember over here is the unique elements. In array, you can have duplicate elements. In set, you cannot have duplicate elements. But there is a similarity with array. The similarity over here is, though set can only allow unique elements, but those elements can be of any type, just like array. So it means that you can keep a boolean, you can keep a number, you can keep a string, you can keep an object in set, but it has to be unique. Also, the similarity with array, like array is an ordered collection, you can retrieve the element back with their insertion order. Same thing also with set. How to create? Pretty simple. Const set equals to new set. We used to do new map, now it is new set. If I do console.log of set, I will have a set created over here. Of course, the set is empty. It doesn't have any entries because we have not added any entries. But just like before, how we had created the map, and while creating the map, we could set some default values into it. For set also, we can do exactly same thing. For example, if you want to create a fruit set, and while creating the set, you want to pass a bunch of entries to it, what you pass an array of fruits over here. So I'm passing array of fruits as a default value to this set. Now if I do a console.log of fruit set, let me correct the spelling as well. What I'm going to get now, I'm going to get a set created with these entries. So let's see that. Yes, I have this set. This is a set, and the set is having those entries that I have passed. Also, the important thing to see over here, that it has a size property. So on the set also, now I can do a size, just like how we do array.length. I'll be able to get how many elements are there. If I expand set, I will see that set is having a bunch of methods over here, like it has add, clear, delete, for each, has, just like map, right? It has bunch of methods, and again, it is an extension of an object. It's time that we look into sets, properties, and methods. For example, one of the property that we have already identified is called size. And there are other methods like has. Let's check out. So let me copy this guy. I can do fruit set dot size. What it is going to give me? I have 1, 2, 3, 4 entries. So it is going to give me 4, right? So this is how I can use the properties. Now let us see few methods. For that purpose, let me create a new set. It's called salad set. We had a fruit set. Now we have a salad set. Now salad set is empty, in the beginning. I want to add a new fruit to it. How can I do it? So there is a method called add. Using that, I can add a tomato. Then using that, I can add other things, other ingredients to the salad. For example, I can add avocado, carrot, cucumber, etc. Now, if I do a console.log of salad set, of course, I'm going to get a set of 4 elements, and I'm going to get all these things inside my salad, right? This is quite good. We know that. Now, if I want to do one more salad set of cucumber, will I be able to do it? I won't be able to do it. Even after this line, if I do console.log of salad set, I will still have 4 elements because cucumber was already added. I cannot add another cucumber to it because it doesn't allow any duplicate elements. That's the specialty of set. So I'm seeing nothing has been changed between these two. It had those 4 items in my salad. The same are there. The cucumber one has not been repeated again, right? Clear enough. Let's go to VS Code once again. Now I want to try out few other methods. For example, has method checks the availability of an element in the set. If the element is available, it's going to return true. If the element is not available, it is going to return false. Now tell me guys, what will be the output of this? Does the salad have a carrot? I have a salad set created over here, and I have the has method. I'm passing carrot. Is it going to be true? Yes, of course, because I have carrot over here. So of course, salad has a carrot. This is going to be true. Similarly, if I want to check whether my salad has broccoli or not, did I add broccoli to it? No, I don't like broccoli, so I have not added broccoli to it. So it means that it doesn't have broccoli, so this is going to return a false. Easy peasy, right? Just like before, the map had a delete method, set is also having a delete method. For example, if I want to delete only the avocado, I can do it by using this delete method on top of my salad set. Pass the element I want to delete is going to delete it off. So now after this, if I print console.log of salad set, it had 4 elements before. Now I'm going to get only 3. I don't see any avocado over here, right? Just like before, we have seen with map, we can also clear it. For example, we can do salad set dot clear, and this is going to clear the entire salad set and to make it completely empty. I hope this is clear. The methods of set, just like map, and there are a lot of similarities in terms of method names, signatures, and the properties, only because if you use one, it is very simple for you to use another one. So with that, we have now covered set in JavaScript, how to create and initialize a set properties and method. Now we are going to learn about how to iterate over set. We know from the map that we had methods like .keys, .values, .entries. What we have for set, so that we can get a set iterator like MapIterator. And once we have the iterator, we know we can use the for each to get the value out of it, right? So let's see how to iterate over a set. First, let's create a set, and we are creating a set of house number, some unique house number we have taken. Now, if you want to create a set iterator of the values, what we'll be doing, you can get the house number, and on house number, you just call the method called values. This will give you a set iterator, and again, you can use a for each on top of it to get each of the values. Just like before, very, very simple. You can use for each, you can use for off to get the things. Now, does set having dot keys like map had a dot keys to get all the keys? No, it doesn't, because it's not a key value pair. There it was entries. Each of the entries in the map was key and value. In case of set, each of the entries are the single element. It doesn't have any key. The keys method also will return the same set iterator to retrieve the value. Please remember, if you do house number dot values and if you do house number dot keys, as set doesn't have a key concept at all. This is going to give a set iterator again. If you do a for each or for off on top of this, you are going to get the same values. no changes. Then how about for entries? I understand for values and keys, entries always give you the key and value pair, right? So what it is going to give? A little bit funny, because key is going to give you the value is also going to give you the value, and entries we had seen before that it used to give us the key value pair. So this is also going to give a set iterator to you, but inside the set iterator, there will be a key value pair where key and value will be the same thing, because there is no key concept. Key and value are the same thing. So if I see the output of this line number 217, just check this out. It has three entries, and see, key and value are the exactly same thing, right? It doesn't make too much of sense to use this one, the entries one, for set. For map it might be. For set, dot values enough for you to use. Just get a set iterator, iterate through it using for each or for up loops, and you are sorted. So that's about the iterator. I hope it is useful. Now let's talk about sets and arrays in JavaScript together. What is their chemistry? What is their synergy? An array is almost like a set. It allows you to add and remove elements. But set is quite different, because it doesn't mean to replace arrays. The major difference between an array and a set is that arrays allow you to have duplicate elements and set doesn't allow you. Also, some of the set operations like delete are much faster than the array operations like shift or the splice we have seen in session number 15, right? So you have to be mindful, like when to use array and when to use a set. Wherever you are going to deal with an unique set of element, you know that there are no chances of any duplication. iClosing will go for sets, because you are able to maintain the unique element. Even if someone trying to add a duplicate element is not going to get added. Second thing, some of this operation, like I told, delete. In case of array, you have shift and splice. Delete is much faster and performative than other shift and splice on array. So think of set as an extension of your regular array. Okay, it is something array plus more muscles. So set data structure is definitely not at all a replacement of an array, but it can also solve certain problems, more interesting problems together. First, let us see how to convert a set into an array. Okay, so you might have this requirement of converting a set into an array. So whenever you have a set, for example, let's talk about this house number, and you want to convert this to an array, simplistic method is use the spread operator. Okay, what it returns to you is an array. Now if I do a console.log of house number array, I won't find it as a set, rather I will find it as an array. Do you see the difference between these two? This is a set which is having its own method, own entries, but the converted one from the house set is an array. This is no more a set. If it is a set, you will find the set written over here as well. You don't find it, it's just an array. If I expand it, the prototype will also tell is an array, and it has the length property. It doesn't have a size property, which set will have usually. Correct? For array, it is always the length property. Okay, and it is also saying the prototype is an array. So to convert a set to an array, just use the spread operator. Now I was talking about that array and set can come together, right, to create something. So for example, if you have an array can accept duplicate elements, and you want to convert that array to a set with unique elements. How do we do it? Pretty simple. Let's take an array of mixed element. For example, mixed fruit. Here I have watermelon repeated multiple times. I have tomatoes repeated multiple times. You can see I have pears repeated multiple times. Now, if you want to convert this to a set, the easiest way would be to pass this array to the set constructor function. So here is a set constructor function that we use to create an instance of a set. I have passed this array over here. Now this particular set that came out of it, if I print it using console.log, it will not have this duplicate watermelon, duplicate tomatoes, or the duplicate pears. It will have only one entries. So the output is going to be a set which is having each of this item only once unique. You see this? This is quite handy and this is quite useful. And this signature that I have used over here is nothing new, right? In the initial stage itself, when I was creating a set, I told you that you can create a set without a value, or you can pass an array itself to create a set. Now, if this array is having duplicate element, the set is getting created out of it, we'll have only the unique elements. Okay, I hope this is pretty clear. Now let me talk about some source of confusions when you want to use objects with set. Okay, so let's take an example. Let us first create a person object. This is a person object. A person has a name called Alex and age, say 32. Okay. Now let's create a set. You guys know how to create a set. Very easy. You can create a person set or p set equals to new set. Excellent. Now inside this p set, if I tell you add this object as an element, you will be able to add it very well, right? You know that there is an add method. Using that, you can add the person to it. Pretty easy. Very good. Now, if you do a console.log of p set, I think no rocket science. It's a set with one element, size is 1, and that element is an object. We can see that. If I expand it, I will find the value of it is that object that I have inserted. Name is Alex, age is 3. Great. Now coming back to the code, let me change the property of this person object. For example, I will do person dot name is having a property. I'll make it as Bob. So I have changed the name of the person. And what I'm going to do, the person name has got changed, right? Now it will be name Bob and age is 32. Again, call the add method on pset and add the person object again. So what is happening? First, I have added a person object, and again I am adding the person object, but the difference between line number 239 and 244 is in between I have updated a property of a person. So what do you think? And the line number 244, whether the pset will have the person object as an element whose name is Alex, or it will be the change name Bob, or there will be two person. I think the possibility of having both Alex and Bob in this set is almost zero, because we know that set can have only unique element. But hold on, is it unique? Because we have changed the name of the person. Is this person is same as this person? What do you guys think? I think the answer lies to that. See, when you are changing the property of an object, you are really not assigning a new object altogether. You are not changing the actual object. We know that when we had created person equals to this object in memory, we had created a location for person, and there this particular value got set. Very initial lesson where we have learned. That is why 40 days of JavaScript is very important, because you get started with all this fundamental knowledge. Now you encash on it to learn something much more advanced. So whenever we are doing const person equals to this object, a memory location for the person will be created, and the memory location will have certain unique address, and in that memory location this particular value will be there, and this person variable will be pointing to that memory location. That's how we know. Now if you're just changing the name of the person, a property, you are not reallocating another new object to this person. That means you are not referencing this person to a new reference in the memory. Memory reference becoming the same person object. Inside that, you're just changing the name. That's it. So it means the person object before and the person object after changing the just a property Bob are exactly same. So as they're referencing to the same instance, that means the person object before and the person object after changing the name are exactly the same. That means there is no point of adding two person over here. It will get added only when this particular person referencing to one object and this person is referencing to another object. Only in that cases there will be two entries get added. As both the references are referencing to the same object, what will happen? It will only have the one person object. Of course, the person object's name, the property will get changed to Bob, but there will be only one entry. You see it over here? It still has the one entry, and that is the object, which is the changed one as Bob. Now compared to this, if I had done this, instead of doing person.name equals to Bob, I can do person equals to a completely new object, and then again assign person to it. I cannot do const here. I'll do let, because I'm assigning, using the same variable to assign the multiple values. Now what do you think? First, the person was this object, Alex object. It got added to the set. Excellent. We got to see this. Actually assigning a new value to it, a new object altogether, right? And again, I'm adding it to the set. Let's see that. Now, if you notice, it has got two entries. Okay. And the first entry, the Alex is there, and the second entry, your empty object is there. Why so? Because these are two different references, and these are completely unique. This particular object instance is completely different from this particular object instance. So set will allow you to add it twice. In the previous case, when we were just changing the property of it, we were not doing a new reference setting, in this case, it was still the same instance. So how many times you add it, it is never ever going to add a new one, because in the set you can only have unique element, you cannot duplicate it. It will always add the latest version of it. If you change the name, change the age, whatever you do. I hope this is clear when you are dealing with set and objects. This is another interview question that people ask. You might get confused sometime. That's why I want you to practice with different values and try to understand it much more deeper. With that, we have covered everything: how to create initialize set, set properties methods, how to iterate over a set, convert a set into an array, unique values from array using set, set and objects. We just need to do set theories now. So let's do some set theories. Okay, so to explain set theories, I think the diagrams that you are seeing on your screen are very, very helpful. We call it as Venn diagram. And if you're from mathematics background, or if you have done mathematics, you know what I'm talking about. There is something called union between two sets. There's something called intersection between two sets. There's something called difference between two sets, right? Now, in the mathematical term, each of these things having its own definition. For example, when you say you do union between set A and set B, it means that the result of an union between set A and set B are the elements in A and the elements in B in either or both of these sets. Okay, that is how it is. That's the union of it. Now, when you talk about the intersection, that means A will have certain elements, B will have certain elements. And when you do intersection of these two sets, it will always be the elements that are contained in both A and B, means the common elements. That's what we have also marked with this color. This is the place which is common between A and B, so it's called intersection. In case of union, it is either and both. Either means it is there in A but not in B, it is there in B but not in A, also it is there in A and there in B, in all the cases. What is difference? In case of difference, if there are two sets, A with some element and then there is another set B with some element, the difference between them will be new set that will contain elements of one set but not containing the element of other set. That is why this portion, the A portion, is in green, because the resultant is contain the elements of A but that are not there in B. Okay, not in common plus not in B as well. So that's the difference. Now, each of this thing, union, intersection and difference, the great news is very recently ECMAScript have added the support for all this method directly into the set collection. So whenever you're working with set, whatever we have done so far, all this method like has, clear, values, all these things. Apart from that, you also have method called union, intersection and difference. This is just a wow, because a few years back, I had to write my own logic to do an union, to do an intersection and do a difference. I'm going to show you those logic as well. But let's first try out union, intersection and difference the way that JavaScript helps us with out of the box methods. Let us take two sets. The first set having 1, 2, 3. The second set is having 3, 4, 5. Now, if I perform an union operation of them, I will get a new set which will have the values, the elements from either of the set and both of the set. So the union of it will be 1, 2, 3, 4, 5. That's what we are expecting. Now, if you're going to use the method provided by JavaScript directly, I'll do console.log of first.union and then pass the second. This will return a new set which contains either and both the elements from both the sets. The resultant would be 1, 2, 3, 4, 5, the union of it. Let's see. Here goes the output of the union. We see it clearly. It is 1, 2, 3, 4, 5 as we expected. Now let's see the intersection. Now similarly for intersection, I'll just copy this line. And instead of union, I'm going to call the intersection method. So what this will do, the first set is having 1, 2, 3, second set is having 3, 4, 5. This is going to give me a new set that will contain the elements that are common between these two. What is the common element? That is only 3. So I'll get a set which will have only one element, and that is the number 3. So intersection, let us see if that happened. Yes, so I got a set which has only one entry, and that is the number 3. That is the intersection between those two sets. Great. Now we'll look into difference. So for difference again, I'm going to copy this guy. Pretty easy, right? And call the method difference. So what is difference? Difference between first and second is only the element that are there in the first, neglecting all the common elements and all the elements from the second. So it means that it is only 1 and 2. because 3 is common between these two, so it will be neglected, and 4 and 5 is part of second. So first and second difference is only 1 and 2 as per the Venn diagram. That's exactly we are seeing over here, 1 and 2, and what we get is also a new set back, and what we get back also a new set. So you understand each of this theory. For union, it is either and both. Intersection, only the common means both. Difference is only in one minus both and other one. That's what the methods are there today directly to give you. But I was saying, right, a few years back, we had to write this method, we had to write this logic by ourselves with whatever JavaScript provide. Also, union, intersection, and difference is a very, very latest edition. It's got added, I think, in 2024, and it is available only in the modern browsers. So if you want to use a browser which is like a little old, or you're working in Node.js where you need it, but you're using a Node.js version less than 22, you won't have this method. That time again, you have to fall back to something which is you have to define or use a polyfill. So let me quickly show you, even if you don't want to use it, what will be the equivalent of union if you want to use it. So what is union? Union is basically getting 1, 2, 3 plus 3, 4, 5, and then get the unique out of this. 1, 2, 3, 4, 5. That is the output we have seen, right? So we can do something like const union equals to I spread and merge both these things. 1, 2, 3, 3, 4, 5. I merge them together and then pass the new array to this set. Won't it work? Yes, it will work. This will also create the same union like 1, 2, 3, 4, 5. This is how we used to do union before. After that, this method is available, so we are able to do it. Similarly, how are you going to do the intersection? Intersection is about finding the commonality, something that is there in both. Now, array is having a very beautiful method, right? It's called filter. Now we can run the filter method on the first array and check that inside first array, if I am having anything matching from the second array. If I'm having anything matching from the second array, that means that resultant array is something I can pass to set to get the new set, which is an intersection, right? So how the logic will be? This is how I can write an intersection. On the first array, why it is array? Because first set I have spreaded. We learned some time back, if we use the spread operator on the set, it gets converted to an array. So this is an array. On this array, we are running the filter method and checking whether but each of the element of the first array is there in the second array or not. If there is a match, filter method always return a new array with all the matched element. We have learned it from the array session, right? So the filter method will return only those elements in an array that is a match between first and second, and in this case only match is number 3. So I'll get one array over here which will have only the number 3, and if I pass that array into the set, I'll get a new set which is having only one entry, that is number 3. So we used to achieve it using this, a combination of array and set together. That's what I was telling, that set and array, if they come together, they become very powerful. All right, now difference. We have a difference directly, but if we had to do a difference between these two, how we used to do? It's just the reverse of it, right? Intersection is about finding the match. The difference is about not finding the match. So we'll apply the same filter. Now we will test it if it is not there in the array. In that case, we can find the difference, right? So the logic will be something like this. Again, on the first converted array, I'm running a filter, but this time I'm checking if it is not present. In this case, it is present. In this case, I'm checking if it is not present, then only I can consider it as a difference. Excellent. I hope you learned something new. Do you know what is this one? This is called superset and subset. A is the superset of B. It means that A has all the elements that B has, plus A has some more elements. That is why B is inside A. So A is the superset of B, and B is the subset of A. Now, this is a mathematical thing, superset and subset. If you have to identify if a set is a superset or subset of another set, how are you going to identify that? For that also, now JavaScript has a method called is superset of. Okay, another handy method. Let's learn that. Okay, I have a set here which is a set of numbers like 2, 4, 6, 8, 10, 12, 14, 16, 18. And I have another set which is 4's table, right? You all of us know table. 4, 4 into 2, 8, 4 into 3, 12, 4 into 4, 16, like that. Now, can you see this 4, 8, 12, 16, 4, 8, 12, 16 also present in the number set. Now looking at this, I can tell the numbers is the superset of the 4 table and the 4 table is the subset of numbers. But I had to manually check If you want to do this programmatically, that is how you will be doing it. Console.log of if numbers dot is superset of the fourth table. This is going to return a true because this guy is a subset of it and this guy is really the superset of this. Correct? Because all these elements are present in this set also. And it has to be, all this has to be present. Then only it is superset. Otherwise it is not superset. So let's see the output. As expected, it is true. Okay, now is a task for you. I will start giving tasks from now itself. The task is, can you think of, without using this direct method, is there a way that you can identify whether number is a superset of the fourth table or not? Okay, just using set, array, all this kind of thing, can you identify? I'll give you one clue. You can very well identify using for loop, and there is a method called has we have seen in the set. Using these two things, for loop and set has method, you can identify whether a set is a superset of another set or not. Of course, in reality, you'll be using the direct method if you have that browser support and everything. But in case you don't have, how are you going to solve this? Can you think of? If you don't find the answer, come to Discord, let's discuss. So that's all about the set theory. Now we are going to move to two more great concepts, which is like WeakMap and WeakSet. Let's cover them. Hey guys, I want to know if you are still there in this session or I'm just talking alone. If you are there in this session, it's a great achievement for me as well. Please post a comment that you are still here till the set theories, and we're going to get into WeakMap. If you have not subscribed to tapaScript, please do that. If you are finding this content good, please post a like. That will be a lot to me. And definitely let me know with a comment that you are still with me and you are also willing to learn about the WeakMap and WeakSet with me. Let's go. As we know about map and the fundamentals of it, I think WeakMap will be pretty easy for you to learn. So let's learn that. Before you go to WeakMap and understanding why it exists, let us talk about few philosophies that we have understood long back. When we discussed about execution context, if you see this image that I'm showing on my screen, does it ring any bell? Yes, this is an image from our execution context video. Here we discussed little bit about garbage collection. Of course, in our next and the last module, you're going to discuss about garbage collection in depth. But here also in the execution context session, we had a discussion about garbage collection. We spoke about something called references and how JavaScript engine keeps a track of the references. For JavaScript engine, it can keep any value in its memory if it is reachable. Reachable in the sense, we spoke about it like you have a reference to it. The moment there is no reference, the moment is like it's a dangling pointer. JavaScript's garbage collection will run its cycle and it is going to claim that memory back, means free that memory back. And that is true for any of the reference type like objects, arrays, functions. We have learned along with that maps and sets, because through prototype chain we have seen maps and sets are nothing but the objects at the end of the day. So this is how we know the things works. Now coming to the code, if I create a user object, for example, name tapaScript. Now this object will be created in the memory. We know it will occupy a memory location and then there will be a value. At later point in time, the moment I do user equals to null, that means there is no reference. We are overriding the reference over here. And now garbage collection is not able to find that any reference to that memory location. So it is going to come and it is going to claim that memory back wherever this particular object was located, and that particular memory will be freed up. This is what I know. Now one interesting thing that I'm going to show you. This user object is there, right? Now in between, let me create an array called all users. And in all users, let me add this user object. After that, as usual, I am doing user equals to null. If I do console.log of all users of 0, what do you think the output will be? I have done user as null, right? So all users 0 is nothing but this particular user, right? Which I have done null. Before accessing only, I have done it null. So am I going to get this particular object or I am going to get null? What do you think? Let's see the output once. Okay, I cannot assign to a constant, so I have to use a let. My bad. So let's use let for this. Now this should run. Let's see the output. The output I see is name tapaScript. I don't see it null, even though I have set the user object as null. It is because this particular data structure, the user, is not defined as null. It means that it is in memory. Now, if this holds another reference type, if that reference has become null, still this array will hold its reference. Understand that? Okay. We have not made all users equals to null. If we had made all users equals to null, again garbage collection would have come and it would have claimed the memory back, freed it up sometime. What we did the user's reference as null. But before that, we have put user as an element of this array. The moment we do like this, like we are putting a reference as an element of another collection, one array, part of an object, until and unless that array, that collection, that object gets freed up, it contains this particular reference within it. So though you are saying that garbage collection is doing its job of claiming this memory of user, still somewhere else inside the collection you're holding this memory. Now this is I'm showing for array. This is exactly true for map also. So for example, if I now create a map just like this, const map equals to new map, and we add map.set method, and we'll have user, we can have the key as an object, and here I can add a value called say true. Okay. So what I have done, I'll get rid of this array for a moment. So I have this user object. I have created a map. I have used this user object as the key of this map and it's having a value. After that, I have set the user object to null as a null reference. So of course, the memory for this user object will be freed up. But with the philosophy that we have learned, as we have used this user object inside this collection, even though it is garbage collected later point in time, this map will still hold this user object. That means the memory is not getting freed up correct way. If I do a console.log of this particular map, even after setting it as null, let's call it as umap, like user map, and let us see the output. I'm seeing this map, and inside that I'm seeing this object, and I'm seeing the key is still that user object, even if I have set it as null. So this is where I think the memory utilization is not really proper when you're using arrays, map, set, objects, and having another reference type inside it. So that is where WeakMap come into picture. This is the background of the WeakMap. And the difference between the map and the WeakMap is the major difference. The key of a WeakMap can only be an object. You cannot have any other primitive values. You cannot have a number. You cannot have a boolean. You cannot have any other things other than the object type. So that means the key you can have as an object, you can have as an array, but you cannot have a number, boolean, etc., string, etc. Why it is? Because when you are using an object as a key of a map or a weak map, you always have an opportunity to make that reference of the object as null so that your memory gets freed up. And instead of map, if you use weak map, JavaScript's weak map will make sure that this particular reference is also gone. In case of map, it was holding it back. In case of weak map, it will be gone. Let's see the difference. So with the same philosophy, let us create another object. Say const, say let addr, which is like address, equals to country, and we'll have say India. Now after this, let us create a weak map. Say wmap equals to new weak map. This is how you will be creating. Okay, you have created a weak map. And the same set method also available on weak map, just like map. You will call the set method. Now you will be using this address as a key, and then you use any value. I'm using boolean type as a value. Only the key must be an object, no primitives, but value can be any standard JavaScript data types. I'm going to make addr my this object equals to null. I'm inviting the garbage collector. Hey garbage collector, come. Whenever your algorithm works, you can just make sure that you can claim this memory, you can free it up wherever the memory location was created for this object. Previously, when we were using map over here, even though we were freeing it up, the user object was contained, the memory was contained inside the map. But in case of weak map now, if I do a console.log of wmap, I will see this addr is no more there because it is gone. It is gone out of memory. Let's see that. Here you go. This is the weak map and I'm showing you the entries. I don't find any because it's got garbage collected. But whereas for the map, we were still seeing the entry. Remember? That's the huge difference between map and WeakMap. That's where you will be using WeakMap. So I hope this explanation was good enough for you to understand why WeakMap is there and where you should be using it. One key difference from map to WeakMap was that map as a key can have all valid JavaScript data types values, but for WeakMap, because of this reason, because it has to deal with the references, the key can be only of object. There is one more difference. WeakMap doesn't support the method like keys, values, entries, all those iterator methods. It supports only 4 methods. What are those? To set, to get, to check whether a value is there by the key, and to delete. That's all it will support. And these are the methods that you can use on a weak map. Whereas in the map, you have other methods to use like keys, values, entries, etc. Is this clear, weak map, to you? I hope it is clear. Now, can you tell me a real life usage of a weak map? Where can you use weak map? Let's see one usage. Okay, let me tell you one usage. Maybe the pseudocode, right? If not the actual code. Let's say you have a HTML element like a div. Now, div may have different metadata, right? Now you want to cache some of the DOM related metadata into a cache, and that cache could be something that till the visibility of the div or a particular HTML element is there on my UI, I can get the metadata. The moment the visibility gone, I don't have to do anything for the metadata. So the metadata object that is there in the memory, I can actually free it up. That's intelligent coding. That's where I'll be taking care of performance. So let's take a look into this code snippet. I have created a metadata map using WeakMap. Okay. Now I have a div in my HTML. Imagine. Okay. Or I can create a div over here. Now what I'm doing a set metadata passing this div itself. Okay. This div itself, which ultimately an object type, and the metadata I'm saying visibility is true. Okay. What set metadata going to do? Set metadata going to take this element, my div, and the metadata info inside this metadata, which is a weak map. Now at any point in time, if this div is taken out of my UI, okay, if this div is removed, in the DOM, we have learned how to remove an element from the parent element, child element from the parent element. You know all this, right? So if this div is removed from your UI, that means this div will be claimed by garbage collector. The memory will be freed. The moment garbage collector claim this div, the memory is freed up. I had added this div using this set metadata method inside this weak map. Automatically, this weak map, this entry for the div will be also deleted. That means you are unnecessarily won't be holding the metadata information of an element that is already removed from the UI. Instead of weak map, if you had used map over here, it would have retained the information of the div and its metadata say visibility true even when the div is removed from the UI. This is a real use case that I can actually take for you. Correct? This is a use case that you need to think about, that if the div is removed from the DOM and dereferenced, metadata is garbage collected. Okay, so this is how it is, one of the example. Now you know about weak map. I think the WeakSet is no more a rocket science. It's exactly the same thing, but in terms of set, it's just like set, but again you cannot have primitives. You should have only objects. That's the difference. In case of set, we could have all the primitives and the objects as the elements inside the set, but in this case it should be only object. What is the reason of it? The reason is same. The objects which should be unique in nature should be put inside a weak set, because set is the collection of unique element, but it has to be an object, because if that object is dereferenced anytime, weak set will make sure that it is removing that element automatically from its collection. That is the main crux of it. Just like map, philosophy same, but applied to set. Okay, so like set, you will have the methods like add, has, then delete, but you will not have methods like again keys, the iterable method, the size properties. All these things won't be available over there, right? So this is what is weak set. How are we going to create a weak set? Let's take an example. For example, let's take const online users equals to new weak set. I have created a weak set, and my intention is I want to track the users who are online. If the users goes offline, I don't want to really spend any memory for the offline users. Okay, now let's create two users. One is Alice, another is Bob. User 1, user 2. What I can do, I can add online users dot add user1. Let me copy this, paste it, make it user2. So what will happen now? If I just do console.log of online users has user1, yeah, it's going to be true. But at any point of time, if user1 becoming null because that user has gone offline, I'm making it null, that means the user1 will be garbage collected. So the weak map, which was tracking this user1, it will not track anymore. It will be outside of it. So WeakSet keeps memory usage very, very lean. In this case, after user1 becoming null, if I'm doing a console.log of this guy again, I'm going to find it false. Let's see. So first time I got true. After dereferencing, I'm getting it false. Awesome, isn't it? Now I have done everything that I have promised you. Okay, I've spent time to teach you. I hope it was useful. Now it's your time to give me back. How are you going to do that? Go to day 33 under 40 days of JavaScript and find the task.md file. You can find it under the tapaScript GitHub organization. If you feel great about it, please follow it. Under that, there is a repository called 40 Days of JavaScript. Here, once the video is published, you will find day 33. Till now, day 32 is there. Just like day 32 is having a task.md file, day 33 also will have a task.md file. Find the task, please do the task, and that is depending on everything that we have learned in this session. And please submit your task to Discord, come to Discord. Let's discuss if you're stuck, and let's celebrate if you are able to learn flawlessly using 40 days of JavaScript. So we'll be back again with the next session, day 34, session 34. Please stay tuned. Keep learning. Be with TapaScript. Don't forget to subscribe. Please like this video and let me know if it was helpful. Thank you very much.